Okay, good afternoon, class. Okay, sorry I'm not in school today. Okay, but anyway, uh, if you have this worksheet, okay, application of chapter 8, application of trigonometry, the one on bearing and elevation, can you take it out now? Okay, and then you all can turn to page 20. Okay, we'll deal with one or two questions here, and then one or two questions from the mensuration chapter, and there will be a revision for today, and then you'll have your test. Okay, all the best. Mr. Lee will come in later to give Mr. Hendrik will come in later to give you all the test. Okay, so let's continue from here. Okay, yeah, we are on page 20 now. Okay, if you all need to read the question for 30 seconds, you all can pause the video here. Okay, you all may want to pause the video at this point. Okay, and then after that, when you're ready, you all can play the video again. Okay, so in the diagram ABC are 3 points, blah blah blah. Okay, first thing first, they want you to calculate angle BAC. Now, here, so this is north, okay, and they want you to calculate this angle BAC, right? Okay, so if this is 300 degree, then this will be, okay, this will be 300 minus 270, which is 30 degree. Okay, so it's 30 degree here. Okay, and you can in fact cut this into two right angle triangle if you want to. Okay, and with this, if not, you can actually use the sine rule to find angle BAC as well. Okay, so I want to use the sine rule here. Okay, the bearing of A from B. Now, so I want you all to recall how to find bearing. Okay, the first thing, you always draw the north. Okay, and you want to identify where is it from. So the bearing of A from where? From B. Okay, so start off with drawing the north. Okay, so the north is upward according to this diagram. Okay, so draw a north from B. Okay, the one of A from B, so basically it's this angle. Okay, so yeah, for you may want to use sine rule again to find maybe this angle, or since you already know this angle, okay, you can then carry on to find, if you're able to figure out this angle, then you should be fine. Okay, basically I just want to go through the principles of how to deal with questions. I'm not going to go through in detail the answers for all these questions. All right, this is just a quick revision. Okay, now the area of the land enclosed by a triangle ABC. Now the area of the land will then be, if you draw a perpendicular line, this length, okay, times this height. Okay, of course there are other ways to do it. For example, if you draw a perpendicular line here, you can find the length of this. Okay, can you? I don't think you can. Okay, so the best way is to do this. So you take this length, multiply with this length. Okay, now next question is slightly more interesting. So a tree is located at B. Okay, now a tree is located at B, that means you need to re-look at this diagram. Okay, so basically you have like a field. Okay, and on top of this field there's a tree growing up at point B. Okay, now the angle of elevation from the top of the tree from A. Okay, so you look up to the tree from A, remember the line of sight. Okay, so if you are at point A, the line of sight is here, the tree is here. Okay, the angle of elevation is this is 23 degree. Okay, then calculate the height of the tree. So from A to B, according to the diagram, is 30 meters. This is the height of tree. So you can just use Tuakaso because this is a 90 degree. Okay, so I think this is it. Okay, now part 2 is slightly more interesting. A man walked from point A to C. Okay, so he walked from all this point to point C. Okay, now you saw a bird in its nest at the top of the tree. So remember that there's a tree here. Okay, so he saw a bird here. Okay, as he's walking along here. Okay, so find the angle of elevation from when he is nearest to the tree. Now, at which point is he nearest to the tree? Is it at this point, this point, this point, or this point? Okay, the point where he's nearest to the tree is the point when he's perpendicularly directly at the tree. So he's walking along the line AC. Okay, and this is point B. You all need to identify that from point B to AC, right? The shortest distance is the line that's perpendicular from B to AC. Okay, I'll give you an example. And I mentioned this in class before. Let's say I have a point A and I have a line BC. Okay, and then I ask you to find the shortest distance from A to BC. No, the shortest distance is always the line that's perpendicular from A to BC, because all other lines, okay, can be seen here. They are going to be longer than the blue line. Yes. Okay, and this is true for our question. Okay, I have a point B here. Okay, let me use black. And let me draw the tree here. Okay, let me use black. So I'm walking along AC and I have a point B here. Okay, from B to AC, right, the shortest distance is the line that's perpendicular from B to AC. Okay, because all other lines, which I'll draw in red, are going to be longer. You see, right? They are longer, right? Okay, so this will be the shortest distance. Okay, now they want the angle of elevation of the bird from the man when he's nearest to the tree. So this is the point we are talking about. Okay, let's call this point Y. Okay, so from YB. Now can we find what is YB? Okay, we can. Okay, if we have this angle, we can just use Tokaso, because you see ABY is just a right angle triangle. This is 30, this is your angle. Okay, this is Y, B and A. So can you find what is BY? You can, using Tokaso, right? Okay, now after we find BY, then what? Okay, then this is what's going to happen. I have a tree at B, right? Okay, and this is point Y. Okay, so I'm the man is at point Y now. Okay, and he's looking up. So line of sight is along this line and he looks up, and they want you to find theta. Okay, early on that question we found that BY can be found, and this is simply just the height of tree, which is found also. Okay, so then basically you have let's call this let's call the top of the tree X. Okay, so basically we have a triangle that's like this. This is the theta that you are interested in. This is Y, this is B, and this is X. Okay, it may be a bit confusing, so you may need to imagine a bit in the 3D model. Okay, so this is it for question 11. Now I'd like to draw your attention to question 12. Okay, now particularly I'm interested in this. Okay, so this is just a diagram, slightly complicated, but it's just a horizontal plane. Okay, so nothing too complicated, just slightly complicated. Okay, so now what I want you all to take note is that, interestingly, right, usually our north is in this direction, but for this question, you all see where's the north? The north is in this direction. Okay, so yeah, nothing too complicated. So sometimes, let's say the north is always here, right? Okay, so what's north in Singapore? Okay, so let's say it's Woodlands. Okay, so let's say you all are sitting facing Woodlands now, right? Then your north, it will be here. But let's say, how if I ask everyone to shift your chair by 45 degrees, right? So now when you shift your chair, you are facing in this direction, but the north is still here. Okay, so according to where you are, right, the north has shifted. Okay, so the north shifts according to where the diagram points it at. For this case, the diagram points it in this direction. Okay, over here, this direction. Okay, so we'll look at north in this direction. Okay, so they want the bearing of A from B. Now the way to do it is still the same. Okay, so you start, they say from B, right? So you start from B, and then you find where is A. Okay, so you connect these two together, remember? Okay, then draw the north from B. So where's the north from B? the north from B is already drawn for you, but just for illustration I'll just draw it again. Okay, the north from B is here, okay, according to the diagram. Okay, not so north is not always here. Okay, you all have to be very careful and look at the diagram where north is. Okay, so bearing of A from B, so starting from the north, go down clockwise until you hit this point. Okay, so this is the angle that you want to find in question A part 3. Okay, clear? Okay, let me give you an example here. Okay, now in this example the north is in this direction. Okay, so yeah, they want to calculate the bearing of C from B. So start from B, okay, draw the north, okay, find C, okay, join this line together. Alright, and starting from north you go down in a clockwise direction until you hit the line BC. So this is the bearing of C from B. Alright, yeah, if you all want, you all can try these two questions. Okay, but I will stop the discussion at this over here. Okay, for this chapter. Okay, and very quickly, I think you are quite good with mensuration. Okay, so everything should be fine. Yeah, but just, and furthermore the formula will be given, so I don't think there should be any problem. Okay, just know that hemisphere is also known as half a sphere. Alright, total volume, so in this case, right, okay, we have a cone and a hemisphere. Okay, so you will take the volume of a half a sphere and the volume of a cone. Okay, just some things to remember, that if I have a cone like this, then I actually can use Pythagoras theorem here. Okay, and we call this the slanted height, we call this the vertical height. Alright, okay, and I hope you all still remember how to find the different areas of different shapes. Okay, went through quite a few in class about cutting using Pythagoras theorem to cut. Okay, so we started off with hexagon, pentagon, a pyramid. Right, and then remember in the pyramid there's a right angle triangle here. Okay, and then we went on all the way to cone, and like I've just mentioned, the cone has also a right angle triangle here. And then finally we went all the way to a sphere, and I also mentioned that in a sphere it is possible to draw a right angle triangle as well. Okay, so I'll just end the video here. Yeah, you all can take some time to do your revision if there's still time until Mr. Hendrik comes in. Okay, all the best for your test later on. See you on Monday. Bye.